Hello students, I am Sravani, working as Assistant Professor in the Department of CSC, Mlritm College, Dundigal. In the last class, we discussed what is logic, what is propositional logic, what are the applications of discrete mathematics, what are the different types of connectivities used in compound proposition. Today we are discussed about logical equivalence. In that we are covered what is tautology, how to construct truth tables, what is contradiction, what is contingency, what are the different laws used in logical equivalence. By using laws of logics, how to construct truth table. Without using truth table, how to prove LHS equal to RHS, and also two types of normal forms. Okay, so first of all, how to construct truth table. So first of all, negation P or Q and P or R. So before construction of any truth table, first observe how many different categories of variables. Here P, Q, R. So 2 power 3 equal to 8. We get 8 possibilities, right? So P, Q, R. How to write 2 power 3 indicates 8 possibilities. That means we get 0 to 7. 0 to 7. How to write 0 to 7 in terms of 2 power 0, 2 power 1, 2 power 2. Possibilities are all are true. Second case, true, true, false. Third case, true, false, true. Fourth case, true, false, false. Fifth case, false, true, true. Next case, false, true, false. Next case, false, false, true. Last case, false, false, false. Here, how to do in these possibilities? First, 2 power 0, 2 power 1, 2 power 2. So we are considered 3 variables. That means in that problem contains 3 different variables. 2 power 0, 2 power 1, 2 power 2. All F's indicates the value is 0. FFT indicates the value is 1. F true F indicates the value is 2. FTT indicates value is 3. How to get 3? 2 power 1 plus 2 power 0. Any number power 0 value is 1. Plus 2 power 1 equal to 3. Next, true, false, false. Value is 4. Next, true, false, true. Value is 5. Next, true, true, false. Value is 6. Next, all truths. Value is 7. So, in that problem contains 3 variables. So, we get 8 possibilities. That means 0 to 7. Okay. So, in that first we solve P or Q. So, this is R symbol, right? Disjunction truth table, disjunction symbol. That means R symbol. R truth table says if all are false, then result is false. Observe PQ. So PQ in this case, both are false, result is false. Result is false. Otherwise, all are true. Okay. Next, negation of PRQ. Already we solved PRQ. Negation means if P is true, then negation P is false. Last class already this one is discussed, right? So P or Q is true, then negation of P or Q is false. Like that, P or Q is true, then negation of P or Q is false. If P or Q is true, then negation of P or Q is false. Like that, we are constructing negation of P or Q. Next, PRR. We are applying disjunction operator in between P or R. P variable and R variable. So observe PRR. What is this symbol? R. R means disjunction symbol. If both are false, then result is false, right? So observe. So last case only, if both are false, result is false. Otherwise remaining it is true only. Next apply negation of PRQ and PRR. So these two, let us consider this is X and this is considered as Y. X and Y, first term and second term. Untruth table says S indicates negation of PRQ and PRR. Untruth table says if both are true, then result is true. So last but one case, if both are true, result is true. Otherwise, it is all are false only. So this is the first example. Let us consider second example. Negation P implies of Q implies R. So in this case, before construction of any truth table, first we are observing how many categories of variables. In this example, we have three variables, P, Q, R. So write down P, Q, R. Okay. So 2 power, how many variables in this example? 3 variables, right? 2 power 3 equal to how many possibilities we get? 8 possibilities. That are false, 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 true, false, true, false, false, true, 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 false, false, true, false, true, 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 false, true, true, true. All false indicates number is 0. Next one. FFT indicates the value is 1. How to calculate this one? 2 power 0, 2 power 1, 2 power 2, like this. So, what is the value of 2? True, false, true, false. Okay. Next, 3. The value of 3 is false, true, true. Next, 4. Value of 4 is true, false, false. Next, 5. 5 value truth values are true, false, true. Next, 6. True, true, false. Next, 7. All truths. True, true, true. Okay. So, first apply Q implies R. Q implies R. This is implication symbol. Implication symbol is also called as conditional symbol, right? So, implication truth table says first variable is true, second variable is false, then result is false. Otherwise, all are true only. So here first variable is Q, second variable is R. So Q implies R. So observe these two. First variable is true, second variable is false, then only result is false. Okay. Next, first variable is true, second variable is false, then only result is false. Here remaining, observe anything is there? No. So remaining all cases, it becomes true only. Okay. Next, negation P. Apply negation P. Negation says if P is true, then negation P is false. Like that we are construct. So P is false, then negation P is true. Okay. True. 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 Here true. False. 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 Okay. Next, apply negation P implies Q implies R. So in this case, first variable is negation P, second variable is Q implies R. If negation P is true, Q implies R is F, then only result is F. Otherwise, it is all are false only. So true, false. True, false. So result is false. So remaining all cases, it becomes true only. Okay, clear? Next, well-formed formula. Well-formed formula is also called as statement formula, which consists of statement variables, parenthesis, colon symbol, connectivities are called well-formed formula. Simply, it is called as WFF. Okay, it is also called as statement formula. Okay, so let us consider some example. Negation P or Q. Check whether the following examples are well-formed formulas or not. So first example, negation P or Q is a well-formed formula. Next, P implies Q and R is not a well-formed formula because here there are two symbols in the second example. One is implication, second one is conjunction symbol. We don't know first which symbol is applied. So here second Q and R parenthesis is missing. So it is not a well-formed formula. Third one, P implies Q and R is also a well-formed formula. Let us consider another example. P and R is a well-formed formula. P implies negation Q is a well-formed formula. PRQ and negation R is also a well-formed formula. What is meant by well-formed formula? It consists of colon symbols, connectives, statement formulas, and also parentheses. Okay, clear? Next. What is meant by tautology, contradiction, contingency? Tautology, a compound preposition which are true for all possible values of a truth values is called tautology. Simply, last column of the truth table all are true, then it is said to be tautology. Tautology is also called as universally truth value. Next, contradiction. A compound preposition all are false, then it is said to be contradiction. Contradiction is also called as absurdity. Contradiction is also called as absurdity. So next, contingency. A statement which is neither a tautology nor a contradiction is called contingency. Simply, we can say that some truth values are true while other truth values are false are called as contingency. Let us consider some examples of tautology, contradiction, and contingency. Show that the following given below is a tautology. Show that means the result is only tautology. So already I told you, before construction of any truth table, observe how many categories of variables in the given example. So here observe this example. Here only two variables. One is P, another one is Q. First write down P, Q. So in this case, we have only two possibilities. Two possibilities means 2 power 2 equal to how many possibilities we get? 4 possibilities. That means 0 to 3. Okay. FF, FT, TF, TT. Okay. Next, negation P. Negation P. Negation says if P is true, then negation P is false. If P is false, then negation P is true. So false here. So negation P is true. P is false, then negation P is true. If P is true, then negation P is false. If P is false, then negation P is false. Okay. Next, negation Q. Observe Q. If Q is false, then negation Q is true. If Q is true, then negation Q is false. If Q is false, then negation Q is true. If Q is true, then negation Q is false. Okay. Next, apply P and negation Q. P and negation Q. Okay. So P and negation Q. This is conjunction symbol. Conjunction truth table says if both are true, then result is true. So observe these two columns: false, false, true, false. Why third variable is true? If both are true, then result is true. Okay. Next, Q or P and negation Q. Already we are completed P and negation Q. Then apply Q or of P and negation Q. So this is or truth table says if both are false, then result is false. Observe these two columns. So these two columns. If both are false, then result is false. Otherwise, all are true. Okay. Next, negation P and negation Q. So apply conjunction in between negation P and negation Q. So negation P and negation Q. So untruth table says if both are true, then result is true. Otherwise false. If both are true, then result is true. Otherwise it is false only. Okay. Next, Q or P and negation Q or negation P and negation Q. Apply Q or P and Q or negation P and negation Q. So in between this is disjunction symbol, that means R symbol. R symbol disjunction truth table says if both are false then result is false, otherwise true. So if both are false, in any case if both are false, no, so it becomes true only. Observe last column. Is there any compound prepositions? No. So observe last column. A compound preposition which is all are true, then it is called as tautology. Therefore it is a tautology. Okay, what is meant by tautology? A compound preposition which is true for all possible values of a truth values is called tautology. Next, verify whether the following statements are tautology or contradiction or contingency. Before construction, what is contradiction? What is contingency? What is tautology? Truth values are true for all possible values called tautology. Truth values are all false is called contradiction. Some truth values are true while other truth values are false are called contingency. So before construction of truth table, what we are observing? How many variables? P, Q, R. So write like that, write down. P, Q, R. So 3 variables means we get how many possibilities? 3 possibilities, right? 2 power 3 equal to we get 8 possibilities. What are that possibilities? False, 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 true, false, true, false, true, false, false, true, false, true, 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 false, true, true, true. Total how many possibilities we get? 8 possibilities. 0, 1, 2, 3, 4, 5, 6, 7. Okay? Clear? So first, in this first, what we are calculating? First, Q implies R. Okay? First, implication truth table says first variable is true, second variable is false, then result is false. So here first variable is Q, right? So true, false, false. True, false, false. Remaining all cases, it is true only. Okay, next. Negation of Q implies R. Apply negation for Q implies R. If Q implies R is true, then negation of Q implies R is false. Like that, we are draw a false true. True means false. Here true means false. True means false. Here false, true. True, false. Okay, next. Negation of Q implies R and R. So, and R. Apply conjunction in between negation Q implies R and R. So, apply this column and R column to which symbol? Conjunction symbol. If both are true, then result is true. Otherwise, false only. False, 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 false. Okay? Next. So, P implies Q. So, P implies Q. Apply PQ, in between PQ, apply conditional truth table. So, true, 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 false, false, true, true. Okay? Next, finally, negation of Q implies R and P implies Q. Apply in between negation of Q implies R and R to P implies Q. P implies Q. So untruth table says if both are true, then only true. Observe, if both are true, then only true. Otherwise it is false only. False, 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 false. So observe last column, all are false. A compound preposition which is false for all possible values of a truth values is called contradiction. Therefore, it is a contradiction. Okay, next. What is meant by contingency? Some truth values are true while other truth values are false are called contingency. In the form of formal definition, neither tautology nor contradiction is called contingency. So P or Q implies P. So only two variables. We get four possibilities. False, 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 true, true, false, true, true. So first apply P or Q. Okay. Our truth table says if both are false, then result is false. If both are false, result is false. Otherwise, true only. Okay. Next, P or Q implies P. Implication truth table says if first variable true, second variable false, then result is false. So first variable true, second variable is false, then only false. Otherwise, it all are true only. So observe last column. Some truth values are true, some truth values are false. That means neither tautology nor contradiction. Therefore, it is a contingency. Clear? Next, logical equivalence. Let us consider two propositions. P and Q is said to be logically equivalent if P double implies Q is a tautology. It is denoted by two symbols by using this one or this one. Is equivalent to this symbol is also logical equivalent. Okay, so the symbol is equivalent to sometimes used instead of triple equal to denote a logical equivalence. Okay, how it write? If and only if P and Q have the same truth values, then it is called as P is logically equivalent to Q. There are two ways to prove logically equivalent by using truth table method. Second one is by using laws of logic. In first method, again divided into two types. By using truth table method, last column it proved tautology. Second way it proves LHS equal to RHS, right? Let us consider an example. P implies Q and negation P or Q are logically equivalent. First method, if both are equal, to prove it is a tautology. How to prove? So see, P implies Q, double implies negation P or Q. So here we have only two variables, right? So we get four possibilities. Negation P means if P is true, then negation P is false. If P is false, then negation P is true. Like that, P is true, false, true, false, false, true, false, true. So P implies Q. So P implies Q means first variable true, second variable is false, then result is false, right? So first variable is true, second variable is false, then result is false. Otherwise, remaining all cases, it becomes true only. Next, negation P or Q applies disjunction operator in between negation P and Q. Negation P and Q. What is the symbol? Or symbol. If both are false, result false. If both are false, result false. Otherwise, all cases, it is true only. Okay. So, this is the given question. Show that the P implies Q and negation P or Q are logically equivalent means by using truth table method, there are two ways, right? One is last column all are true method, second one is LHS equal to RHS method. So by using S indicates P implies Q, double implies, by implies negation of P or Q. This is called as by implies. By implies truth table says that if both are same, then result is true. Otherwise it is false only. If both are same, result is true. If both are same, result is true. That means if both are same identicals. Identical means both FF either true. So if both are true, result is true. If both are true, result is true. Observe last column, all are true only. So this is the first method to prove the logical equivalence. Second method. Apply if both P and Q are same truth values, then it is said to be logically equivalent. So the given question, P implies Q and negation P or Q. So before construction, what we are observing, how many variables? So two variables, P and Q. So 2 power 2 equal to how many possibilities we get? 4 possibilities, right? What are the 4 possibilities? True, true, false, false, true, false. Then apply negation of which variable? P only. So if P is true, then negation P is false. If P is true, then negation P is false. If P is false, then negation P is true. If P is false, then negation P is true only. So next, P implies Q. P implies Q. So P implies Q. Implication. First variable true, second variable false, then result is false. Observe PQ. So apply these two cases, implication truth table. If first variable true, second variable is false, then only result is false. Otherwise, remaining cases, it is true only. Next, negation P or Q. Apply disjunction operator of negation P and Q. So apply these. Disjunction truth table says if both are false, then result is false, right? So here, if both are false, then result is false. Remaining all cases, it is true only. Observe P implies Q and negation P or Q truth values. Here true, here also true. Second row, false, false. Third row, true. Fourth row, true. So P implies Q is equivalent to negation P or Q only. What is meant by logical equivalence? Both P and Q having the same truth values. Observe TT, FF, TT, TT. If both P and Q are same truth values, then it is said to be logically equivalent. So let us consider some laws of logics. So first one is idempotent law. So each and every law contains two symbols, one associated with two symbols. One is R symbol, another one is AND symbol. So R symbol is primal forms, AND symbol is dual form, right? So idempotent law, P or P is equivalent to P. Dual form, P and P equivalent to P only. Identity law, P or F is equivalent to P, P and T is equivalent to P. Domination law, P or T is equivalent to T, P and F is equivalent to F. Complement law, P or negation P is equivalent to true, P and negation P is equivalent to false. Associative law, are you observe? P R Q R R is equivalent to P R Q R R. That means in first left hand side, first two variables having parentheses. Right hand side, 2-3 variables having parentheses. That is associative law. P R Q R R is equivalent to P R of Q R R. That same time dual form, P and Q and R is equivalent to P and of Q and R. Okay. Next, commutative law says P R Q is equivalent to Q R P. P and Q is equivalent to Q and P. Okay. Next, distributive law. So each and every symbol associated with 3 1. Okay. So the small tip is 3 variables, 2 different symbols using distributive law. How to distribute this one? Let us observe how many variables here. P, Q, R. 3 variables with 2 different symbols. One is R, another one is Q. How to distribute this one? P, R, Q and P, R, R. Same way, for example, it contains in middle and R. So P and Q or P and R, like that. That is called as distributive law. Absorption law. So 2 different variables, only 2 variables. P or of P and Q is equivalent to P. P and P or Q is equivalent to P. De Morgan's law. Apply negation. So negation of P or Q is equivalent to negation P. Negation of R is equivalent to and. Negation P and negation Q. That means dual form of this formula is negation of P and Q is equivalent to negation P or negation Q. Negation law, double negation law, not negation law, double negation law. Negation of negation P is equivalent to P only. Next, conditional law. Mainly we are using P implies Q is equivalent to negation Q or P. Double negation law. P implies Q is equivalent to P implies Q and Q implies P. This first one is very, very important. What are the 2 laws? Conditional law. P implies Q is equivalent to negation P or Q. P double implies Q is equivalent to P implies Q and Q implies P. These are the laws. Laws of logic contains 2 methods, right? Using truth table method. Second one is laws of logic method. So using truth table method to show that are logically equivalent. So here without using truth table, let us say without using truth table. Without using truth table means what we are using? Laws of logics only. So first P implies Q and P implies R is equivalent to P implies Q and R. Given question, P implies Q and P implies R is equivalent to P implies Q and R. Let us consider LHS. P implies Q and P implies R. So here we are observing P implies Q. What is the conditional law? P implies Q is equivalent to negation P or Q. What is this law? Conditional law. Right? So P implies Q, negation P or Q. So here also observe P implies R. Apply same conditional law, negation P or R. Okay. Next, apply distributive law. Apply distributive law. So in both 2 terms, negation P is common, no? So negation P or Q and R. Okay. So distributive law. What is meant by distributive law? P or Q and R is equivalent to R and P or R and Q, right? So negation P or of Q and R. Apply conditional law. P implies Q is equivalent to negation Q or negation P or Q. So here we have right hand side. So write down P implies, in place of Q is Q and R. So P implies Q and R. Therefore, P implies Q and P implies R is equivalent to P implies of Q and R. Okay. Next, second example. Prove that logical equivalence without using truth table. So first we are observing left hand side. Let us consider LHS equal to P or Q and P or negation Q or Q is equivalent to P or Q. Okay. So only we are consider LHS to prove LHS equal to RHS, right? So are you observe square brackets in between PRQ and PR negation Q? If both two terms observe P is common, right? So apply distributive law. Apply distributive law. So P or Q and negation Q or Q. Okay? Q and negation Q is equivalent to 2. So are you observe? Previously we are P or negation P is equivalent to false. P and negation P is equivalent to false. So here P and negation, let us consider P and negation P is equivalent to false. So P or false or Q. P or false is equal to false. So, sorry, P. Finally, P or Q. Therefore, P or Q and P or negation Q is equivalent to P or Q only. Okay, clear? Next, consider another example without using truth table, using laws. Negation P implies Q implies R is equivalent to Q implies P or R. So here first we are consider implication law, right? So this is P, consider as this is P, this is Q. What is the formula? P implies Q equal to negation P implies Q. So negation P. So negation of negation P or Q plus in the form of Q, negation Q or R. So negation of negation P, double negation law. So negation of negation P equal to P or negation Q or R. So associative law, that means of P or negation Q or R. So here commutative law says B and Q equal to Q and B. So like that Q or P or R. So here by apply again associative law. Negation Q R of P or R in before first two variables having parentheses. What is the associative law? Next two variables having parentheses. So this is apply conditional law. P implies Q equal to negation P or Q. So in case of applying formulas, we are using right hand also, left hand also. Here right hand is there. So negation P or Q. So apply left hand side. So negation P or Q. Q implies P or R. Next, normal forms. There are 4 types of normal forms used in discrete mathematics. First one is conjunctive normal form, second one is disjunctive normal form, third one is principal conjunctive normal form, fourth one is principal conjunctive normal form, principal disjunctive normal form. Totally 4 types: CNF, DNF, PCNF, PDNF, right? Before discussing normal forms, what is elementary products, what is elementary sum? Okay, these are the basics of normal forms. What is meant by elementary product? The product of variables and their negation in a formula is called elementary product. For example, product means and symbol, sum means R symbol, right? Product of variable and their negation. Okay, product means which symbol? And symbol, right? Product of variable means P, Q, R, like that all are called as variables. Variables is nothing but propositions. So P and their negation of that variable negation Q is called elementary product. For example, P, single P is a elementary product. Negation of P and Q, product of elementary variables and their negation. Okay, next, product of variable and their negation. Fourth example, product of variable and their negation. Product of variable and their negation are called elementary product. Next, elementary sum. Sum indicates which symbol or symbol. Elementary sum means the sum of variables and their negation. Sum of variables and their negation is called elementary sum. Let us consider some examples. P, negation P or negation Q, negation Q or negation P or negation P, like that. These all are elementary sum example. What is meant by elementary product? Product of variables and their negation is called elementary product. What is the product symbol and symbol? Okay, what is meant by elementary sum? First, sum means or symbol. Sum of variables and their negation is called elementary sum. How many types of normal forms are there? 4 types, right? Disjunctive normal form. Sum of elementary products is called disjunctive normal form. So, sum means which symbol or symbol? Sum of elementary product. What is meant by elementary product? Product of variable and their negation, right? Product of elementary sum and their variable and their negation. Let us consider one example. So here in between the variables, which symbol is there? Sum symbol. Sum of elementary products are called disjunctive normal form. What is meant by conjunctive normal form? Product of elementary sums. Product in between the elements contain which symbol? Product symbol. In which form? Conjunctive form. So product of elementary sums are called conjunctive normal form. So find DNF of negation of P implies of Q and R. So find DNF form. First, what is meant by DNF form? Sum of elementary products. Sum of elementary products. What is the formula? So what is the given question? Negation of P implies Q and R, right? So negation of, so apply conditional law. What is conditional law? P implies Q is equivalent to negation P or Q only. So negation P or Q and R, right? So apply negation law. Negation of negation P equal to P. Negation of R is and. Negation Q, negation R. Okay. Next, again apply distributive law. How to apply distributive law? P and negation Q or P and negation R. Observe the result. Sum of elementary products are called DNF. Okay. What is the result? What is the solution of negation of P implies of Q and R? P and negation Q or P and negation R. Thank you.